Hello learners, welcome to this session. So what is computer networking? Computer networking refers to connected computing devices such as laptops, desktops, servers, smartphones and tablets and an ever expanding array of IoT devices that communicate with one another. So what are its characters? Why we have to connect the computers? Basic characteristic features of computer networks are sharing, speed, scalability, integration, security, and cost effectiveness. Sharing means computer networks enable sharing of files, software, hardware resources, and computing capabilities. So once the systems are connected, you can share the files, you can share the resources and other features. So the other important feature is the speed. The communication speed among the components is fast enough to be comparable with a centralized system. The other important feature is the scalability. The sizes of computer networks dynamically increase with time. It allows to scale. Then the other feature is the integration. All the components of the network work in a coordinated manner for a seamless user experience. So suppose if the standalone systems are there, you have to move from desk to desk in order to copy a simple file. If they are connected, then you and the permission is granted, then you can directly access the system and you can access the file also. And obviously the next followed feature is the cost effectiveness. So how does a computer network work? Computer networks connect nodes like computers, routers, and switches using cables, fiber optics, or wireless networks. These connections allow devices in a network to communicate and share information and resources. Networks follow protocols. These are nothing but a kind of guidelines which define how communications are sent and received. These protocols allow devices to communicate. Each device on a network uses a internet protocol or IP address, that is nothing but a string of numbers that uniquely identifies a device and allows other devices to recognize it. Routers are virtual or physical devices that facilitate communications between different networks. They analyze information to determine the best way for data to reach its ultimate destination. Switches connect devices and manage a node to node communication inside a network, ensuring that bundles of information traveling across the network reach their ultimate destination. So let us see the network components. So there are hardware devices, there are software components attached whenever we focus on the computer networks. Computer network components comprise both physical parts as well as the software required for installing computer networks both at organizations and at home. So the hardware components are the server, the client, peer, transmission medium, and connecting devices. The software components comprises of the network operating system and the set of protocols. So let us focus on some of the hardware components. While we are discussing about the how network works, so there we had heard about routers, switches and other kinds of physical components. So let us focus on one by one. The first one is the server. Servers are high configuration computers that manage the resources of the network. The network operating system is typically installed in the server, and so they give us the access to the network resources. Servers can be various kinds. For example, file servers, database servers, print servers, application servers. Likewise, you can quote several kinds of servers. The other hardware component is the client machines. Clients are computers that request and receive service from the servers to access and use the network resources. Then comes the component called as the peer. Peers are computers that provide as well as receive services from other peers in a workgroup network. Then the important component, which is the transmission media. Transmission media are the channels through which data is transferred from one device to another in a network. Transmission media may be guided media like coaxial cable, fiber optic cables, etc. Or may be unguided media like microwaves, infrared waves, etc. The other physical component in a network is the connecting devices. So, connecting devices act as a middleware between the networks or computers by binding the network media together. Some of the common connecting devices are routers, bridges, hubs, repeaters, gateways, switches. So each and every component we had discussed over here as the connecting device has its own functionality. Coming to the software components, the major software component is the network operating system. So the network operating system is typically installed in the server and facilitate workstations in a network to share files, database, applications, printers, etc. So this particular operating system has its own functionalities in order to support all these functionalities. Protocol suite. A protocol is nothing but a rule or a guideline followed by each computer for data communication. Protocol suite is a set of related protocols that are laid down for computer networks. The two popular protocol suites are OSI model, that is Open System Interconnections model, and then TCP IP model, Transmission Control Protocol, Internet Protocol model. So this is a kind of computer network components. You can see here there are various physical components, the router, bridge, hub, so repeater, the workstation, the peer connections. So everything is depicted in the single diagram. You can identify the server, you can identify the client machines. So this is a kind of diagram wherein which you can know which device is connecting what and what is the functionality of each and every hardware component. So coming to the network applications, computer systems and peripherals are connected to form a network. They provide numerous advantages like resource sharing such as printers and storage devices, exchange of information by means of emails and FTP. It allows information sharing by using web or internet. It facilitates interaction with other users using dynamic web pages. It allows IP phones, video conferences, parallel computing, instant messaging, charting. Likewise, there are several network applications we can quote. And then there are various types of computer networks. Network is not a simple thing. Depending upon the geographic location, we can define different types of computer networks. Geographic location often defines a computer network. For example, a LAN connects computers in a defined physical space like an office building, whereas a WAN, wide area network, can connect computers across continents. The internet is the largest example of wide area network connecting billions of computers worldwide. So let us see just a hierarchy wise types of computer networks that we have. Personal area network, that is PAN, local area network, LAN, metropolitan area network, that is MAN, wide area network, that is WAN, and then virtual private network. So where these particular networks differ, that we will see one by one. First one is the personal area network. A personal area network is smallest network which is very personal to a user. This may include Bluetooth enabled devices or infrared enabled devices. So personal area network has connectivity range up to 10 meters only. So PAN is the smallest network. So PAN may include wireless computer keyboard and mouse, Bluetooth enabled headphones, wireless printers or TV remotes. So all these examples comes under the personal area network. Here we can quote another example. Piconet is Bluetooth enabled personal area network which may contain 8 devices connected together in a master slave fashion. So you can explore by using the Google that what is Piconet. So next comes in the hierarchy is the local area network. A LAN is a collection of connected devices in one physical location such as home or an office. A LAN can be small or large, ranging from a home network with one user to a large enterprise network with thousands of users and devices. A LAN may include both wired and wireless devices. Regardless of size, LAN's particular characteristic is that it connects devices that are in a single limited area. So in the hierarchy, it comes in the second position. The third one is the metropolitan area network, that is MAN. So the MAN generally expands throughout a city such as a cable TV network. It can be in the form of Ethernet, token ring, ATM or FDDI, that is fiber distributed data interface. Metro Ethernet is a service which is provided by ISPs. This service enables its users to expand their local area networks. For example, MAN can help an organization to connect all of its offices in a city. Backbone of MAN is high capacity and high speed fiber optics. So this is the advantage that the MAN is getting. Metropolitan area network works in between LAN and WAN. It provides uplink for LANs to WANs or internet. The next in the hierarchy is the wide area network. It extends over a large geographical area and connects individual users or multiple LANs. The internet can be considered as a WAN. Large organizations use WANs to connect their various sites, remote employees, suppliers and data centers so they can run applications and access necessary data. Physical connectivity in WANs can be achieved by leased lines, cellular connections, satellite links and by other means. The other network that we can discuss here is the virtual private network. In short, we can call it as the VPN. A VPN is a secure point-to-point connection between two network endpoints. So a VPN establishes an encrypted channel that keeps a user's identity and access credentials as well as any data transferred inaccessible to hackers. So this is a very secure kind of computer network. Then let us see there are two types of network architecture. So the first type is peer-to-peer. In short, we can call it as P2P. And the second type is the client server, which is very much popular network architecture. So in the P2P architecture, two or more computers are connected as peers, meaning they have equal power and privileges on the network. A P2P network does not require a central server for coordination. Instead, each computer on the network acts as a both client and a server that serves the needs of the client accessing the service. Each peer makes some of its resources available to the network, sharing storage, memory, bandwidth, and processing power. Coming to the client server network, which is a second type of network architecture, a central server or a group of servers manage resources and deliver services to a client devices in the network. The clients in the network communicate with other clients through the server. Unlike the P2P model, clients in a client server architecture don't share their resources. This architecture type is sometimes called as a tiered model, like a single tier, two tier client server, or else entire client server. So this is because it is designed in a multiple levels or else in multiple tiers. So the network will be arranged in such a fashion, and the arrangement we call it as the network topology. This is very important in order to understand the kind of topologies that one uses in their organizations. So a network topology is the arrangement with which computer systems or network devices are connected to each other. Topologies may define both physical and logical aspect of the networks. Both logical and physical topologies could be same or different in the same network. So there is one thing called as the point to point. So this is the simplest arrangement. Point to point networks contains exactly two hosts such as computer, switches or routers, servers connected back to back using a single piece of cable. Often, the receiving end of one host is connected to sending end of the other or vice versa. If the hosts are connected point to point logically, they may have multiple intermediate devices. But the end hosts are unaware of underlying network and see each other as if they are connected directly. The second type of topology is the bus topology, which is very much popular. In case of bus topology, all devices share single communication line or cable. Bus topology may have problem while multiple hosts sending data at the same time. Therefore, bus topology either uses CSMA oblique CD technology or recognizes one host as bus master to solve the issue. It is one of the simple forms of networking where a failure of a device does not affect the other devices. But failure of the shared communication line can make all other devices stop functioning. Both ends of the shared channel have line terminators. The data is sent in only one direction, and as soon as it receives the extreme end, the terminator removes the data from the line. The third topology that we can discuss is the star topology. All hosts in star topologies are connected to a centralized device known as a hub device using a point-to-point connection. That is, there exists a point-to-point connection between host and hub. The hub device can be any of the following, like layer 1 device such as hub or a repeater, layer 2 device such as switch or bridge, layer 3 device such as router or gateway. As in bus topology, hub acts as single point of failure. If hub fails, because that is a centralized point, if hub fails, connectivity of all hosts to all other hosts fails. Each communication between hosts takes place through only the hub. Star topology is not expensive as to connect one or more hosts. Only one cable is required and configuration is very much simplified. In the ring topology, Each host machine connects to exactly two other machines, creating a circular network structure. So you can see a ring is nothing but a kind of circular arrangement of computer network. When one host tries to communicate or send message to a host which is not adjacent to it, the data will travel through all the intermediate hosts. To connect one or more hosts in the existing structure, the administrator may need only one more extra cable. Failure of any host results in a failure of the whole ring. Thus, every connection in the ring is a point of failure. There are methods which employ one more backup ring. The next topology that we can discuss is the mesh topology. In this type of topology, a host is connected to one or multiple hosts. This topology has hosts in point-to-point connection with every other host, or may also have hosts which are in point-to-point connection to few hosts only. Hosts in mesh technology or mesh topology Hosts in mesh topology also work as a relay for other hosts which do not have direct point-to-point links, and mesh topology comes in two types. One is the full mesh and the other is the partial mesh. The other topology that we can discuss here is the tree topology. This is also called as the hierarchical topology. This is the most common form of network topology in use at present. This topology imitates as extended star topology and inherits properties of bus topology. This topology divides the network into a multiple layers of network. Mainly in LANs, a network is bifurcated into three types of network devices. The lowermost is access layer where computers are attached. The middle layer is known as distribution layer, which works as mediator between upper layer and the lower layer. The highest layer is known as core layer and is central point of the network, that is root of the tree from which all nodes fork. All neighboring hosts have point-to-point connection between them. Similar to the bus topology, if the root goes down, then the entire network suffers. Every connection serves as point of failure, failing of which divides the network into unreachable segment. So apart from the star topology or other kinds of topology which we had discussed, the computer networks has several models. One is the simplest model called as the layered network model. The other is the OSI model, and the third one is the TCP IP model, or else you can call it as the internet model. Let us focus on layered network model. In layered architecture of network model, one whole network process is divided into small tasks. Each small task is then assigned to a particular layer which works dedicatedly to process the task only. Every layer does only one specific work. In layered communication system, one layer of host deals with the task done or to be done by its peer layer at the same level on the remote host. The task is either initiated by a layer at the lowest level or at the topmost level. If the task is initiated by the topmost layer, it is passed on to the layer below it for further processing. The lower layer does the same thing. It processes the task and passes on to the lower layer. If the task is initiated by lower most layer, then the reverse path is been taken to go upwards. Every layer clubs together all procedures, protocols and methods which it requires to execute its piece of task. All layers identify their counterparts by means of encapsulation header and tail. Open system interconnection is a open standard for all communication systems. OSI model is established by International Standard Organization. You can call it as the ISO. This model has 7 layers altogether. Application layer. This is responsible for providing interface to the application user. This layer encompasses protocols which directly interact with the user. Then comes the presentation layer, which defines how data in the native format of a remote host should be presented in the native format of host. The other layer is the session layer, which follows the presentation layer. This layer maintains sessions between remote hosts. For example, one user password authentication is done. The remote host maintains this session for a while and does not ask for authentication again in that span of time. In the transport layer, this is responsible for end-to-end delivery hosts. The function of the network layer is it is responsible for address assignment and uniquely addressing hosts in a network. The next layer is the data link layer. This layer is responsible for reading and writing data from and onto the line. Link errors are detected at this layer. The lowermost layer is the physical layer. This layer defines the hardware, cabling, wiring, power output, pulse rate, etc. This layer is completely dealing with the physical devices and other components. Then the next model is the TCP/IP model, or else you can call it as the internet model. Internet uses TCP/IP protocol suite, also known as internet suite. This defines internet model, which contains 4-layered architecture. OSI model is general communication model, but internet model is what the internet uses for all its communication. So the internet is independent of its underlying network architecture, so is its model. This model has the following layers: application layer, transport layer, internet layer, link layer. So next comes the internetwork or the internet. So a internet of networks is called as an internetwork or simply the internet. It is nothing but it is a network of networks. It is the largest network in existence on this planet. The internet usually connects all the WANs, that is wide area networks, and it can have connections to LANs and home networks. Internet uses TCP/IP protocol suite and uses IP as its addressing protocol. Present day, internet is widely implemented using IPv4 or IPv6. Because of shortage of address spaces, it is gradually migrated from IPv4 to IPv6. Internet enables its users to share and access enormous amount of information worldwide. It uses www, file transfer protocol, email services, audio and video streaming, etc. At huge level, internet works on client-server model. Internet uses very high-speed backbone of fiber optics. To interconnect various continents, fibers are laid under sea, known to us as submarine communication cable. Internet is widely deployed on www services using HTML linked pages and is accessible by client software known as web browsers. When a user requests a page using some web browser located on some web server anywhere in the world, the web server responds with proper HTML page. The communication delay is very low. That is, the latency will be very low. So let us talk some of the applications. Even in the next videos also we can see several applications of internet. Internet is serving many applications. Some of them are, it is helpful to host the websites, to check our emails, instant messaging, blogs, social media tools, marketing, networking, resource sharing, audio streaming, video streaming, VoIP. So there are several internet applications. And with this particular backdrop, like the computer networks backdrop and the internet backdrop, we will proceed on for the next coming 4 videos. So the next video will be focusing on history of internet. So with this, I'll conclude this session. Thanks for watching.